Hello everyone, welcome back to the channel. In today's video, we are going to talk about a very important change in FortiOS. Starting with version 7.6.x, Fortinet has discontinued SSL Remote Access VPN. That means, going forward, organizations that rely on remote connectivity will need to migrate to IPsec Remote Access VPN. This makes it essential to understand not only how to configure IPsec Remote Access VPN on your Fortigate, but also how to verify, troubleshoot, and secure it properly. In this video, I will walk you through the complete configuration process, show you FortiClient setup, and share some of the most useful diagnostic commands to help you troubleshoot when things don't go as planned. By the end of this video, you will have a clear understanding of what is IPsec Remote Access VPN, how to deploy IPsec Remote Access VPN on a FortiGate with confidence. So let's get started. When we are talking about IPsec, we have to understand IKE. So IKE is the protocol that is responsible or that establishes the secure communication for the IPsec tunnel to be established. So before we begin the configuration of IPsec remote tunnel, we need to just understand a few basics about the IKE. So whenever a IPsec tunnel is established, let me quickly take pen. So whenever a IPsec tunnel is established between a firewall or between a remote device, the communication is secured using the IKE, or they negotiate using the IKE. If you want IPsec to work properly, that means IKE connections should be allowed and phase 1, phase 2 should negotiate. Hope everyone knows this, but I'm just giving a basic overview about this. Let's say you have a client here, and this is a FortiGate or any other device, any other VPN device. If you want to have a IPsec VPN tunnel between them, IPsec tunnel, or you can say remote access IPsec tunnel, FortiGate should be reachable from the client on port 4500 if it is behind a NAT device, and otherwise the default port is UDP 500, which is like when there is no NAT travels enabled. So for a client to establish a tunnel with FortiGate, you should have 4500 and 500 port reachable from the client to the FortiGate. This should be reachable. This is the first requirement. Okay. Then second, the phase 1 and phase 2 parameters should be configured correctly. So what is phase 1? A simple overview. Phase 1 negotiates the encryption mechanism that will be followed between the client and the FortiGate to establish a secure communication. And then phase 2 uses the parameters taken from phase 1 to rekey or to establish the encryption for the data transfer. So phase 2 is actual data transfer, like the encryption for the data transfer, and phase 1 is the security mechanism, you can say, and phase 2 depends on phase 1, of course. So if any of these fails, the tunnel will not come up. So what you have to check is, check UDP 4500 and 500 connectivity between the client, verify phase 1, phase 2 parameters, verify phase 1 and phase 2 parameters. Okay. Now, this IKE is in two versions, IKE V1 and V2. V2 is a more secure protocol and V1 is the older method. So you can either use IKE V1 or V2, but to secure or to have and more security, now IKE V2 is preferred. Okay, so this is the IKE, the basic setup for the IPsec. So IPsec to work, you should have Internet Key Exchange. So IKE stands for Internet Key Exchange. Internet Key Exchange. This protocol is used for establishing a secure communication between the client and the server, or between site to site IPsec VPNs, and this works on port 4500 and 500, negotiates tunnels, private keys, authentication and encryption, and it is in phase 1, phase 2 and version V1 and V2. So this is what the IKE is, and this is important to establish an IPsec tunnel, be it a remote access tunnel or a site-to-site tunnel. In this case, in our case, we will be using it for the remote access VPN. When we talk about IKE version 1 and IKE version 2, as I mentioned, there are two versions. So what are the main differences like? So IKE V1, they have got two modes, man mode and aggressive mode. Man mode is where total 9 messages are exchanged between the client and the server, or you can say client and the Fortigate, or between two sides, client and server. Server means it is a like the VPN concentrator or the VPN provider device. In aggressive mode, there are total of 6 messages are exchanged between the client and server. 6 for phase 1 and 3 for phase 2 in the man mode, and 3 for phase 1, 3 for phase 2 in the aggressive mode. So basically, aggressive mode reduces 3 messages and makes it faster. So if you want to have less number of message exchange between the client and server, then aggressive, otherwise man mode. Whereas in IKE V2, one exchange procedure only, total 4 messages, one child essay. That means the work that was being done in IKE 1 in 9 or 6 messages exchange is getting done or completing in 4 messages under IKE V2. From this, what we can conclude, IKE V we can say faster because of lesser messages exchange. Now, IKE V1 is a symmetric encryption or a symmetric authentication method, and it can verify by using pre-sealed keys, certificate signature, and XAuth. Whereas IKE V2 is asymmetric, and it can authenticate PSK, certificate signature, and EAP. So instead of XAuth in IKE V1, there is EAP authentication in IKE V2. So EAP is now much more faster. So this is the second reason you should prefer IKE V2, like EAP, because of the EAP support. Earlier it was XAuth. Net reversal. Under IKE 1, this is supported as an extension. Extension means when you take the debugs, like it is a not part of the protocol itself, but it is an added extension. But the NetT is a part of the protocol, part of the IKE V2, and it's not an extension to the protocol. So this also makes it better. Unreliable messages are not acknowledged. That means UDP, maybe we can say. Of course, it is UDP, but this is messages are not acknowledged. But here we have the option of messages are acknowledged. Again, IKE V2 I will prefer. Then in the dial-up we have got peer ID plus aggressive mode plus PSK. Here it's peer ID and network ID. So this again makes it faster because of the type of authentication. And the last one is, of course, traffic selector narrowing.
So here it's not supported, and under IKE v2 it's supported. So these are the main differences between IKE 1 and IKE 2. Now, what we are focused in today's video is the remote access VPN. Remote access VPN, IPsec Remote Access VPN. Remote users connect to corporate resources. Fortigate is configured as a dial-up server. Only clients can initiate the VPN. Users require a VPN client such as FortiClient. So what we have remote users with FortiClient installed on the clients. These are the clients, different client. It can be a PC, a phone, or any other device which can support a FortiClient. Okay, so the users use FortiClient to establish a remote access VPN with the Fortigate. So Fortigate is configured as a dial-up server. So this Fortigate will be a dial-up server or the VPN device where the VPN will be terminated. So once these devices establish a IPsec communication with the Fortigate and the tunnel is established, all the communication from the client to the backend server or the end protected device, we can say protected network or protected host or protected network. Protected host or protected network is encrypted inside a tunnel. So there will be a tunnel between Fortigate and the client PC, and all the data is encrypted in this tunnel. So once the data is encrypted, any outsider or any third party or even the devices sitting here, they will not be able to read the data. Because this is a encrypted data. So this is what is remote tunnel or remote access VPN tunnel from a user to the device to the FGT, and the data between the client and the server is encrypted by using the encryption protocols that are part of the IPsec exchange and that were negotiated during the beginning of the tunnel. So user will be authenticated and then the tunnel will be established. The user authentication can be local user from Fortigate, can be a LDAP user which can be part of AD, can be a SAML authentication, or any other database, can be a Radius authentication, can be a TechAx authentication. Okay, so these all different type of users are supported for the tunnel or for authentication on the Fortigate. Let's talk about how to configure the remote IPsec VPN. When we configure remote IPsec VPN, there are two methods. One is manual method. One is manual, and the second method is by using a wizard. Wizard is an automatic wizard. Okay, there are two methods, manual and wizard. So on the screen, what you are seeing is the wizard. Wizard means which is a automated, very easy to set up. So IPsec wizard is a easy to set up method by which you can set up IPsec VPN. During the configuration, what we have to do is we have to go on VPN IPsec wizard, or you can also go on create new and then IPsec tunnel and follow the wizard. There are two methods. Okay, so IPsec wizard, click on VPN setup and you have to select remote access VPN. When you select remote access VPN, which kind of remote device it is? So we discussed that the remote device is a client based. So you have to select the remote device type, that will be client based and FortiClient. Select and then click on, you will see a next button here after this. Okay, you click next. Authentication. Then the second part of this wizard is authentication. Under the authentication, it will ask for you the incoming interface. So incoming interface means the interface on which the FortiGate will listen for VPN or will connect to VPN. For example, if this is your FortiGate, okay, and this interface P1 is connected to internet. So the incoming interface for the VPN will be the P1 port 1 interface, right? So whichever interface is your incoming on which the user will connect, or the IP of this interface will be the remote gateway in the client. So this interface will be selected as your incoming interface. Authentication method. So either you can choose pre-sealed key or you can have a signature based. So signature based means the certificate authentication. So you have to bind a certificate in case of signature. Okay, certificate, and signature uses certificate. Pre-sealed key, you have to define the pre-sealed key, and this pre-sealed key you have to provide it to all the clients that are going to connect to the IPsec VPN, because during the configuration of the FortiClient, there you have to input the pre-sealed key. So it is a pre-sealed key that you have to provide it to the end user to configure it. Or if you are having a EMS based or managed FortiClient, then you can deploy all these profiles from the EMS automatically to all the clients, and you don't have to do, like, user don't have to know the key, because that can be pushed, the complete profile can be pushed from the EMS server. So you have to select the pre-sealed key, define the pre-sealed key, and select the user group. User group means this is the group who will be authenticated or who will be allowed to connect to VPN. Who will be allowed to connect to VPN. So this user group is users allowed to connect to VPN. Users to VPN. So this group is the users to allowed. Okay. Then you have to click next. The next step is selecting the local interface, local address. Local interface, local address is similar to a site to site. For example, what you have to do, this is your client. Okay, this is your client. This is connecting to a FortiGate. Okay, when you are connecting to FortiGate, what will happen? This FortiGate will have the local subnet or the LAN that you want to access using the VPN. There can be multiple interfaces or VLANs, interesting traffic. So that is also called interesting traffic, LAN, or let's say DMG, or different sub-interfaces or different networks that are behind this firewall. So local interface means to which interface you want to allow the VPN users to connect, or the subnets or the interfaces that VPN user can access from the VPN. So this port, for example, is P1, okay, and this LAN port is P2, DMG is P3. So local interface you will select as P3, this port, and P2. So you can click on a, if there are multiple interface, you can click on P2 also. And then local subnet. So local subnet will be the subnet that you want VPN users to access in. So for this, for example, this is 10.10.10.x, and this is 10.20.20.x, these two subnets. So in this case, you will select here the local subnet of 10.10 and 10.20. Both will be selected in the local address. So local address is the address that VPN users will be able to connect. So basically, this VPN wizard is asking all this because it is going to create the firewall policy, the rules, the address objects, everything by its own. So that's why calling all these parameters during the wizard helps us to create all the firewall policies, address objects, everything by its own. So that's why it's asking everything in one step. Then client address range. Client address range is the IP address that you are going to assign to the client IP. So this client IP will also get an IP address to be connected. So this is the range from where the IP address to the client will be assigned, and subnet mask for this. DNS server, you can use system DNS. System DNS means it will use Fortigate DNS, or specify if there is any other DNS rather than the one that is configured on Fortigate. Enable IPv4 split tunnel. This is important. Once you enable the split tunnel, so only the subnets that are part of this local address and that you define under the split tunnel will be allowed from the FortiClient VPN, and rest will go to the internet, their normal default gateway, and whatever you define under this split tunnel will be allowed to come from the FortiClient VPN. So it is like these routes will also be pushed to the client. So once you enable the IPv4 split tunnel, you have to define the subnets that are allowed under the tunnel. Allow endpoint registration. Allow endpoint registration is for getting the client all information and registering the EMS client or the FortiClient on the FortiGate as a client. So this is an optional, like not mandatory. Once you do all this, then you will get next. You have to click on next. Once this part is done, you will come on the last page, which is the review page. Review page, what you have to do? Split tunnel group. If you have enabled the split tunnel, because in the previous step we enabled the split tunnel, that's correct. Phase 1 interface, phase 2 interface, FCT range. FCT range is this FortiClient range for this IP address. Then we have remote to local policies, VPN FCT remote, endpoint registration. So these all naming address will automatically created based on this wizard. So why it is everything is like FCT split, FCT, because the tunnel name we have given here the as FCT, right? You can see the name was given FCT. Once you review the setting, then it gives the client options, like you want to allow the client to save the password, auto connect, or keep alive, and you have to select all these parameters. As soon as all this is done, your remote access VPN is configured, and it's very easy by using the IPsec wizard. Once this is done, then you have to configure the phase 1 proposal or phase 2 proposal. Even if you don't do this, by default, all these parameters are configured as the default parameters, but you have to match these proposals with the client. So when you are configuring this on the client, you should match. So under phase 1 proposal, you get the encryption mechanism. Yeah. So once you go to the setting, you need to define the phase 1 proposal, like the encryption and authentication. You can choose one or multiple. If you have multiple, then it can match one of them, whichever based on what is negotiated between the client. You have to select the Diffie-Hellman group for the phase 1. Stronger, like the bigger the DH group, stronger the encryption. Key life and local ID. Similarly, okay, now this encryption is supported, like what all different encryptions are supported. So if you click on this drop down, you will be able to see DAS, 3-DAS, AES 192.2. So these are all the encryption mechanisms that are encryption algorithms. I'm sorry, these are the encryption algorithms that are supported under phase 1. And authentication is MD5, SHA-256, SHA-384, SHA-5112. Whatever you select, you should select based on your organization security policy or based on what is considered strong as per your organization requirement. Higher the encryption, higher security for the data, and higher utilization or processing time for the firewall as well, because it requires more encryption and strong encryption. So you have to select the phase 1. Then you have to do the phase 2 proposal. So phase 2 determines the encryption algorithm. You can configure multiple proposals for added flexibility. Impacts performance and hardware offloading. The more stronger you select, impacts performance, as I told you, because if the encryption algorithm is strong, the CPU needs to process it more for the encryption. So you can enable replay detection to protect against ESP replay attacks, which is a local setting. What are different phase 2 settings that are available is phase 2 proposal, that is the encryption, replay detection, perfect forward secrecy, Diffie-Hellman group, local port, remote port, protocol, key lifetime, and seconds. Okay. So when you are doing this configuration, make sure you configure the same on the client side as well. They should be exactly matching with the client. If they are not matching, then the tunnel will not be established and you will get an error like assay proposal, no assay proposal chosen, no assay proposal chosen. This is the error that you will get, no assay proposal chosen, if there are mismatch between the client and the server, client configuration and the Fortigate server. So there are different errors that you might receive, and mostly the issue are due to the misconfiguration between the client configuration and Fortigate configuration. 99%, or based on my experience, I can say 90% of the issues in the IPsec tunnels are due to the negotiation or the misconfiguration between the client and the server. Once you have done both phase 1 and phase 2, then you have to select the subnets that are allowed, like during the manual configuration. This is all manual configuration. So what phase 2 selector does is, phase 2 selector determines the encryption domain. Encryption domain means the subnet or the traffic that is allowed under the IPsec VPN. So we have to choose what is the local and remote address that needs to be encrypted. So determines the encryption domain. You can configure multiple selectors for granular control. Multiple selectors means like multiple subnets that are allowed when the VPN. If traffic does not match a selector, it is dropped. So make sure like all the subnets that you are planning or that should be encrypted and should pass by the VPN are defined here. In point-to-point VPNs, selector must match. The source on one FortiGate is the destination setting on the other. So it's like a mirror. We also say the selectors should be exactly mirrored between the remote and client. This is done. Your IPsec tunnel is configured. That's it. You don't have to do anything. Now just go to the FortiClient, configure the same IPsec profile, and you are done. Now, how you can monitor? IPsec routes appear in the routing table after phase 1 comes up if the remote gateway is set to static IP address or dynamic address. So when you go under dashboard network IPsec, you will be able to see the phase 1 and phase 2 selectors, and you will also get a route in your dynamic routing once the VPN is connected. So if you check the VPN, you will see like dial up as green once the client is connected, and you will see a route lookup which will be pointing to the remote IPsec VPN tunnel. So this is how it looks like once the VPN is connected. And you will be able to monitor all this under log and report, system events, VPN events, and you will see like the IPsec progress, is it success, which state it is in, VPN tunnel progress IPsec, IPsec connection status change, install IPsec. So all these logs are available under system events, VPN events. I will also show you the FortiClient configuration during the lab. You know, we always do all this on a lab. So I will create a tunnel, connect a client, everything we will do in the lab. How to troubleshoot? So you can use these various commands: diagnose VPN tunnel, bring it down, bring it up, list all the tunnels that exist on FortiGate, and flush. Flush means clear the tunnel. Like it's like session gets cleared and then reestablish it again. Flush tunnel. So it's like flush. That's it. Gone. Clear it. Clear the mess. So flush means disconnect all the sessions for the VPN and then try to reestablish again. So you can flush one tunnel, all tunnel at a time, or you can just define the name of the tunnel that needs to be When you are doing troubleshooting, you can see diagnose VPN tunnel list and the name of the tunnel you have to provide, and you will be able to get all these details about the tunnel. Okay, so this all you will be able to see using this command. Now you can also use get VPN IPsec tunnel details, which shows the phase 1 details, local gateway, remote gateway, IKE mode 1, the interface on which it's listening, the RX and TX packets, and if you are getting any errors in the tunnel during the transmission. The selectors, the MTU of the interface, IPsec interface, phase 2 SA, and the hardware acceleration. Diagnose VPN IKE gateway list using this, like when the tunnel was created, is this gateway initiator or respond, and how we can clear the phase 1. So for clearing the phase 1, you have to use IKE VPN, diagnose VPN IKE gateway clear. So if you use this command, you will be able to clear the phase 1 interface of a tunnel, clear phase 1. And using flush, you clear the phase 2. Now, what are the common IPsec problems generally we get? Common IPsec problems. Most common is tunnel is not coming up. So if the tunnel is not coming up, what generally I have seen is negotiation failure or no SA proposal chosen. So negotiation failure is due to IPsec configuration match, and no SA proposal chosen is also due to IPsec configuration match. What happens like IPsec configuration? So what you have to do is, in both these scenarios, you have to verify the phase 1 and phase 2 parameters, and 90% of the issues gets resolved by properly validating the configuration between the client and the server. Then you will get tunnel is unstable. So this can be due to DPD. So DPD means dead peer detection, and if there is no keep alive received, then DPD can bring the tunnel down and can again bring it up once it is back. It can be due to ISP issues or DPD not being received due to a connection issue, due to cable issues, due to your layer 1 or layer 2 issues, or dead peer DPD not configured same exactly on both the sides, and net travels. The third most common issue is tunnel is up but traffic does not pass through. So in this case, you have to enable the debug flow and see the IPsec selectors. So in such cases, mostly the issue is because of the IPsec selectors. There will be a mismatch in the IPsec selector, which will result in tunnel going down when the selectors that are not configured but traffic is received. So there it will not match, and the tunnel may go down intermittently based on the selectors. So what is the common issue? Traffic not matching quick mode selector, and NAT is enabled. So verify quick mode selectors are correct. Disable NAT on the VPN firewall policy if that does not exist. And the routing issues. So it can be a intermittent routing, or your traffic is not passing properly via the correct routes. So route missing or pointing to wrong devices. So these are like the various possible issues. So not various, I can say 99% of the IPsec issues falls under these three categories. Tunnel is not coming up, tunnel is unstable, or tunnel is up but traffic doesn't pass through. And all of them, most of them will get resolved by doing a proper configuration validation. And now lab time. Let's configure a remote IPsec tunnel between a Fortigate and a FortiClient. Let's begin.
I'm here with our lab, and we have the Fortigate and a remote client. We have got a Windows client and our Fortigate. So this Windows client will be connecting via remote access VPN to our FortiGate. The topology is like on WAN 1 interface, the client is connected and he will be connecting to VPN on WAN 1. And for better understanding of the IPsec VPN, let's just quickly make a diagram for this, how we are connecting. So during the wizard configuration or manual configuration, it will be easy to create the tunnel because we already have everything ready. So we can Fortigate FGT. This FGT, the client is connected on WAN 1 port. Here is my client. Okay. WAN 1 IP is 10.31.6.11, and then I have another interface which is port 1 where my LAN can be there or the interesting traffic can be there, and I have got one more interface, loopback interface. I just created for a testing loopback interface. This loopback I have given the name as SSL VPN loopback. Okay, so what we will be doing is we will establish a tunnel on WAN interface. What is the subnet for port 1? 10.5.10.5.134.11. 10.5.134.x. So this is my LAN. Now we have to configure the remote tunnel, enable it on WAN interface, interesting traffic for 10.5.134. That's it. Okay, and we have to create a firewall policy, but this will all be taken care by the wizard. Let's begin. What you have to do is, I told you there are two methods, manual and wizard. This wizard can be invoked by going from VPN IPsec wizard and follow this wizard, select remote access VPN, or even if you go under IPsec tunnels, create new IPsec tunnel and then follow the wizard. So in both the ways you can use whichever way. So let's make it easier. Click on IPsec wizard, give the tunnel name, for example Rosa Lab. Now what kind of VPN tunnel this will be? This will be a remote access and based on FortiClient. Select incoming interface. You remember our topology? What was our topology? Our topology was WAN 1 the client is connected, right? The WAN 1 client is connected. So we have to select the incoming interface as WAN 1. Pre-shared key, define any pre-shared key that is secure. Now user group. User group means which users are allowed to connect, as I explained. So I have got a guest group already created. In this guest group, I have a VPN user part of the group. So these users can connect to the VPN, or these user groups can be depending on your organization. It can be remote user, LDAP user, authentication, like any other kind of authentication. So you have to select that group, whichever group it is. So these groups can be like, if you go under user authentication, user groups. So you see these groups listed here. So on your firewall, you will have your own groups or you have to create your own groups. Remote access, next, incoming interface, WAN 1, pre-sealed key, you have to select the pre-sealed key, the group, my group. Click on next. Local interface, what is my local interface for this? So here my local interface is this port 1. Okay, port 1 is my local interface. Port 1 is my local interface. Now what is my local address? Local address is this. This is local. Okay, so it is 10.5.134. So I can select like 10.5.134 if I have port 1 range.
10.5.1.34. I have already created the object. Client address range. What IP address I am going to assign to the client when he is connected? So let's take, for example, I will give 192.168.20 dot to the client. So I have to specify here 192.168.20 dot 10 to how many clients. So basically in the wizard you have to give a range for the client until 192.168.20 dot, let's say 50. I have 30 users for example, so or 40 users from 10 till 50. Subnets, I'm giving individual subnet mask, or I can define a /24. But even if I give single /32, that means they all are going to have a individual route on the firewall, or I can add one go like /24. Use split DNS server. Use system DNS. System DNS means the DNS server that is defined on the Fortigate will be received by the client as their DNS server for any DNS query towards the VPN tunnel. Enable IPv4 split tunnel, or you can even specify. If you click on specify, then you have to specify your DNS server that you want to use. Use system DNS and at this click on next. I want like FortiClient should be able to save the password. If you want yes, auto connect, yes, you can choose these options. Say next and then review the settings. So Rosa Lab is split because my tunnel name was Rosa Lab. Phase 1 interface, phase 2 interface, address range, policy and create. So now my tunnel is set up, done. So once this says the VPN has been set up, it's set up. Your remote IPsec VPN is configured. That's it, done. Part is done. So because of this wizard, if you see what all changes occurred, if you go under the firewall policy, you will be able to see one firewall policy created from the VPN interface towards port 1. So this is created due to the wizard. Then we have got this address object created. And now if you go under VPN IPsec tunnels, you see this tunnel is created. Created on which port? WAN 1 port, and it's inactive. Now let's check the configuration. Now you can check all the parameters that were configured because of the wizard. So you can see here the incoming interface, client range that we defined, authentication and the user group. If you click on edit, you will be able to choose or modify them. Open FortiClient VPN. VPN is open and I have to click on add a new connection. Under add a new connection, choose IPsec VPN and give the tunnel name, any name you can define here, Rosa Lab IPsec Remote for example. What is the remote gateway? What is the firewall IP on which I have to connect? Do you remember? I think this 10.31.6.11, that's my firewall IP. 10.31.6.11. Pre-shared key. Then advanced settings. So these advanced settings is what you see here. Okay. So by default, let's say whatever is there, it should be like IKE v1, man mode aggressive. These are defined, and even if you check on the firewall side, you will see advanced convert. Okay, now I think due to the default configuration, it should be same. Let's try to connect. We are not changing anything here. We'll just click on save and let's see if it connects. My VPN user name is VPN user and password. Let's try to connect. Not connecting, right? Why not connecting? It must be some configuration mismatch, right? So for I told you like you can check the events under system events and VPN events, right? So what you can see here, VPN events, failures, negotiate failure, right? Negotiate error. So the peer essay proposal not match local policy. IPsec phase 1 error. So the phase 1 parameters are not matching. What is not matching? Phase 1 parameters are not matching. So we have to configure the client exactly as what is there on the Fortigate. Okay. Now let's match everything quickly on the client. Pre-shared key. Okay. Let me open the client again. Add a new connection. IPsec VPN. Rosa Lab. My 10.31.6.11. I think that was my IP. Yes. Okay. Pre-shared key. I forgot my key myself. Let me type the key. Okay, just we are using the default key for now. Okay, and then click on edit. Will match exactly. I will define the key. Then what we have? We have second. Okay, so we have IPsec IKE version 1, expand VPN setting, pre-share key version, man mode aggressive, and then aggressive, accept any peer type. Okay, so this part is done. Phase 1 proposal. Now let's match the phase 1 proposal. Expand phase 1. What we have? AES 128 and SHA-1. Okay, and AES 128 SHA will remove anything else. No need. Simple will make it easier. We have AES 128 and SHA 256. Okay, that's it. So first one will match. Then we have default group here 20, and on the firewall you see 14 and 5. So because of this it was not matching. The phase 1 was not matching. Okay, and let's go to phase 2. Phase 2 advanced, and we have 14 and 5 as the diffie element on the phase 2, 14 and 5. So let's select 14, 43200, and all this AES 128 SHA-1 matches. Let's remove this unwanted. We don't want to get confused. We'll match only what we need. Okay, click here OK, click here OK, and everything on the client shouldn't match now. Okay, now let's try. No, it's no, sorry, it's VPN user and password of the user. Let's try to connect. Looks like it's still not. Events, VPN events. Yeah, it's failure. Oh no, why? Why it's failure? Okay, now it's aggressive, progress IPsec phase 1, negotiate failure error. Okay, so now you see what are the challenges. Challenges on all the challenges are about the misconfiguration. So once your tunnel is fully configured, all parameters are matched, then it's very easy for IPsec. So right now I have the misconfiguration. So I have not matched the parameters correctly. So this is what you have to check always. Okay, added the selected connection. Let's verify again. Advanced settings, VPN settings, version 1, aggressive, mode config. Okay, phase 1, AES 128, 14 and 4, net travel cell. Let's check here. IPsec tunnel. This is done. Phase 1 proposal. Let's check the phase 1 proposal. phase 1 AES 128*256. Okay, this is matching, and even this is matching. DH group is 14.5, we matched. Okay, net traversal, head route. Okay, this is enabled, net traversal enabled. Okay, DPD on demand, DPD on demand, net traversal enabled. Okay, then phase 2 AES. Okay, phase 2 43200. Let's check phase 2. Phase 2 advanced. AES 128 SHA-1 43200 PFS. PFS is enabled, yes, and replay detection is enabled. Okay, and key life is 43 days. That's it. So now everything matches. Mode aggressive 192.168. Save login. Click save and connect. Log and report events, VPN event. Failure. Why failure? This is the bigger issue, because we are not matching the parameters properly. Now let's do the debug. Diag debug application IKE -1. Diag debug enable. This is the command to enable the debugs. And let's do this again. We'll see exactly what's happening. Okay, now we can see here ASA proposal chosen, matched gateway Rosa Lab, aggressive mode first, VID okay, created connection, peer supports Unity, enable fail to compute DH shared secret, connection expiring due to phase 1 down. So now we know the issue. The issue is coming because of fail to compute DH shared secret. Maybe the pre-shared key is not correct, I guess. Negotiation is chosen. So our parameters are matching. DPD negotiated, peer this is done, enable FortiClient compliance check, net the fail to compute DH shared secret. Okay, so when it says fail to compute DH shared secret, that means mostly the issue is because of the negotiation on the DH group. So if we check this, edit the selection, phase 1 we are selecting 14 and 5, and in phase 2 we are selecting 14, but during the negotiation it might have chosen 5. Okay, so let's remove 5. Why? Because if phase 1 is chosen as 5 and DH group for the phase 2 is 14, which is higher, then it will be a problem. So you should choose the higher one here. Okay, click on save. Now again try to connect. But now on FortiGate, I think yeah. So see, now the tunnel is connected. Okay, tunnel is connected. Go to IPsec tunnels, and the tunnel is up. You can see tunnel is up. If you go under network and dashboard, monitor routes, network routing, you will see these routes like 192.168.20.10 is pointing towards the tunnel because this IP is assigned to my client. So the tunnel is connected. That's it. This is all how to configure a IPsec Remote VPN. For troubleshooting of IPsec Remote VPN, I will be creating separate different videos. Today we saw one issue which is like fail to compute DH shared secret. So fail to compute DH shared secret means the DH group that is being matched under the phase 1 is lower than what is configured in the phase 2. So what we did is we choose in the higher DH group on the phase 2, which fixed our issue of connecting. So now the VPN is connected and you will be able to see tunnel is established. Even on the FortiClient side, you will be able to see like this VPN is connected, and we should be able to ping a IP address which is behind the firewall, the interesting traffic 10.5.31.11, I guess. No, what is my, I gave the interesting as port 1 10.5.134.11 10.5 ping 10.5.134.11. Yeah, so I am able to ping or reach the interesting traffic from the VPN. And if you check it using like the monitoring, if you go under network, dashboard and VPN, I think VPN monitor should be there, IPsec. Yeah, you see the tunnel is established, remote gateway, the peer ID, incoming data and outgoing data you will be able to see, and this is up. So these are the phase 1 and phase 2 selectors for this. If you check the same under log and report, events, VPN events, you will see the tunnel status was success. So that's it. This is how we configure the IPsec Remote Access VPN. Thank you everyone. Thank you so much for watching. See you in the next video.